Data transmission. What is data transmission? The movement of data from one digital device to another is known as data transmission. Transmission medium. Guided media. The physical medium that is used to transfer information bits from one computer to the other. Unguided media. Methods that allows the transmission of data without use of physical means. Practical data transmission. For real-life approach, data communicate between two or more devices at the same time. Next, data needs to transmit over a long distance to allow people sharing the information around the globe. Then, data should be maintain the highest data rate to prevent noise interference. Lastly, digital signal need to convert into analog signal to transmit in different bands. Therefore, the wireless communication is important for people nowadays. Wireless communication, the transmitter and receiver can be placed anywhere. Multiple users can be communicating at the same time. What is modulation? Modulation is the process of converting data into electrical signals optimized for transmission. Next, the information signal is converting into high band frequency from low band frequency that's suitable for transmission medium. Then a modulator is used to convert information signal into modulated signal, and a demodulator is used to convert back the modulated signal into information signal at the receiver end. Advantages of modulation. Firstly, the communication range increases. Multiplexing of signals occur, thus multiple users can communicate at the same time. Next, the adjustments in the bandwidth is allowed, therefore signals can convert into different formats. Lastly, modulation can prevent the problem of the range of communication gets limited as the wave cannot travel to a distance without getting distorted. Types of modulation. Amplitude modulation, frequency modulation, and phase modulation. Amplitude modulation. Amplitude modulation is a process by which the wave signal is transmitted by modulating the amplitude of the signal. It is often called AM and is commonly used in transmitting a piece of information through a radio carrier wave. Amplitude modulation is mostly used in the form of electronic communication. There are three main types of amplitude modulation. They are double sideband suppressed carrier modulation, single sideband modulation, and vestigial sideband modulation. Frequency modulation. Frequency modulation is a modulation in which the frequency of the carrier wave is altered in accordance with the instantaneous amplitude of the modulating signal, keeping phase and amplitude constant. Modification of carrier wave frequency is performed for the purpose of sending data or information over small distances. Frequency modulation use cases include FM radio broadcasting, magnetic tape recording systems, monitoring newborns for seizures via EEG, radar, seismic prospecting, sound synthesis, telemetry, two-way radio systems, and video transmission systems. Phase modulation. Varying the angle of a wave in a carrier in order to transmit analog or digital data. For digital signals, phase modulation is widely used in conjunction with amplitude modulation. Phase modulation is widely used for transmitting radio waves and is an integral part of many digital transmission coding schemes that underlie a wide range of technologies like Wi-Fi, GSM, and satellite television. It is also used for signal and waveform generation in digital synthesizers.
Next, let us move to radio digital modulation. Radio digital modulation means that the information signal is digital signal. There are three techniques that can be used, which are amplitude shift keying, ASK, frequency shift keying, FSK, and phase shift keying, PSK. In amplitude shift keying, The digital signal is used to switch the carrier amplitude. When the digital signal is high, the output will be the amplitude of carrier signal. Otherwise, when the digital signal is low, the output will be 0. In frequency shift keying, the waveform can be generated by adding two amplitude shift keying waveform together with a summing amplifier, which is shown here. Two ASK is summed together to form a FSK waveform. Next, for a PSK, the modulated signal is depending on the digital signal input. When there's a change of state from 1 to 0 or 0 to 1, there will be a phase change in the modulated signal. However, this technique has some limitations, such as bandwidth is restricted. Is there a way we can increase the data rate to allow more bits per baud? The ways is using quadrature phase shift keying, QPSK. With QPSK, the carrier undergoes 4 changes in phase. One symbol represents 2 bits. A symbol represents 200 bits of data, which is 00, 01, 10, and 11, total of 4 bits. The phase difference is 90 degree. QPSK changes from 45 degree to 135 degree to 225 degree, and lastly to 315 degree, which is shown here. 45 degree to 135 degree to 225 degree, and lastly to 315 degree. This may seem insignificant, but the QPSK modulation scheme enables a carrier to transmit 2 bits of information instead of 1, which effectively double the data bandwidth of the carrier. This figure shows the 4 phase in which the carrier is sent in, which is 45 degree, 135 degree, 225 degree, and 315 degree. So therefore, QPSK is better than PSK because of the efficiency in the frequency spectrum is equal to 2 bits per second per hertz.
Recently, 5G is a hot topic. 5G is a great advancement in communication field which will lead human to another great generation. "5G is coming Malaysia." Digital National Berhad comments 5G service on Ericsson-built network in Malaysia. 5G is now available in parts of Malaysia. For example, Putrajaya, Cyberjaya, and Kuala Lumpur. Ericsson launched the country's first innovation center of 5G in partnership with the UTM. Well, TM and YTL will be the first operator to offer 5G service in Malaysia. 5G. And what is the impact of 5G? 5G is a reliable, super fast speed, massive bandwidth, and low latency of network. 5G will leading to new possibilities in products and service with the potential of an increase in productivity. What is the benefit of 5G? 5G will bring benefits to society, environment, financial service, economy, and healthcare. With 5G, we can connect to more devices, from self-driving car to smart Bluetooth, and even coffee machine. 5G will assist us in transforming industry, giving remote access to robots and managers for improved safety in risky environment. There are some misconceptions of 5G in terms of health. Recently, there is a conspiracy theory that coronavirus can be spread through 5G. It is real. In 2020, 4th April, there is a news that British 5G towers are being set on fire because of coronavirus conspiracy theories. However, what is the truth is, according to the WHO World Health Organization, 5G mobile networks do not spread COVID-19. Virus cannot spread through radio wave and mobile networks. COVID-19 is spreading in many countries that do not have 5G mobile networks too.